Well, my name is Alejandro and I'm going to explain about my thesis project. It is a construction of a three-wheeled directional mobile robot using Swedish wheels, 3D printing, and Leopard-based controllers. So let's start. Well, mobile robots are systems capable of moving through different environments using sensors or programmed actions. Among them, optidirectional robots stand out because they can move in any direction without needing to rotate first. This makes them ideal for operating in tight or narrow spaces. To achieve this, the robot uses Swedish wheels. These wheels allow lateral, diagonal, forward, backward, and smooth rotational movement. Thanks to them, the robot gains high flexibility and stability. Even though directional robots offers excellent mobility, controlling them is not as simple. Their movement is not linear, not non-linear, meaning small changes in speed can create very different motions. On the top of that, the motors have limitations. They cannot always react fast enough or generate the required torque. This can cause saturation and some tracking mistakes. Classical controllers such as PI, PT, or PIT do not perform well with nonlinear dynamics. They often produce slow responses and large mistakes and unstable motion. For that reason, this project will use Lyapunov-based controllers. This approach helps keep the robot stable even under a non-linear movement, reducing mistakes and improving the trajectory tracking performance. To build this robot, we will use open source hardware such as a Arduino or Raspberry Pi and the others. This makes these platforms makes the robotic more accessible because they are not expensive. They are cheaper, easy to program, and compatible with such as many electronic devices. 3D printing also play a role and a key role here. It allows us to fabricate custom parts quickly and at a low cost, making the design easier to improve or modify. The main goal of this project is to build three-wheel operational robot controlled with a Lyapunov-based constructed sorry again with a Lyapunov-based theory capable of following paths with good stability. The whole platform is a low cost. The problem statement it's the most mobile robots cannot move sideways because they have non-holonomic movement limits. This makes them less efficient in small or tight spaces. To reach a point on their side, they must perform several movements which is slow and not very precise. These movement limits also reduce accuracy when following a path or keeping a stable position. The general objective is, of course, is build a omnidirectional robot printed in 3D and controller using Lyapunov theory. But the specific objectives are design and 3D print the robot chassis, implement the electronic system of the three-wheeled platform, develop the control program using Lyapunov-based controllers, and validate the robot's performance through simulations and laboratory tests. I'm sorry again. The justification is about observational robots can move easily in narrow spaces where conventional robots struggle. This makes them useful for support tasks, safe transportation of tools, or an operation in a limited environment. The project also has a social education impact because the platform is a low cost. It can be adopted by schools, communities with limited budget. At the same time, it is strength skills in a mechanical design, mathematical modeling, nonlinear control, and experimental testing, core topics in mechatronics engineering. This project focused building and testing three-wheel observational robot capable of moving in the X and Y plane. The main goal is verify stable and precise trajectory tracking using Lyapunov-based controller. The scope includes the mechanical design, the electronic integration, Bluetooth communication, simulation, and laboratory tests on smooth indoor surfaces. However, the project not include autonomous navigation, obstacle detection, sensor function, or real industrial deployment. The limitation. The robot is designed for indoor operation under stable conditions. It uses 3 Swedish wheels to follow predefined trajectory on a 2D plane. The platform is low cost and runs the control system for trajectory executions. It is powered by a 12 volts supply and has a maximum weight of 3 kilograms. And thank you very much. This is everything for me, and that's it.